Hello atmospheric science students, Dr. Shragi here, and I want to go over how to compute sun angles with you. Keep in mind, the reason why we're doing this is because lots of people had trouble with the homework, the sun angles on there. Are sun angles on the tests? Yes. Are you going to have to compute sun angles and problems related to sun angles? Yes, you are. Are they the most important thing in this unit? Of course not. How much are we talking about? The test has 60 questions, and there's maybe 3 or 4 that are related to sun angles. You certainly can do just fine without doing it, but I think everybody wants these points, especially considering these sun angle problems really aren't all that hard. One of the keys to understanding sun angle problems is to remember how to use that diagram called the analemma. Remember, the analemma is a diagram used to find the latitude of the solar declination. In case you don't remember that definition, the solar declination is the latitude at which on a given day the sun will be directly overhead at noon. It's a diagram, it's that one that kind of looks like the figure 8, and the y-axis is latitude, and the kind of figure 8 thing is actually a calendar. And as you go around the outside of the calendar, you can find dates, and you just find a particular date and read across over to the y-axis to get the latitude of the solar declination. If I were trying to give you the formula for sun angles just in words, I would say that it is the sun angle is equal to 90 degrees minus a distance. And that distance has to be the distance between the latitude that you're given in the problem and the solar declination, which you got off of an analemma. So why do we say distance instead of saying add this one or subtract this one? It has to do with you have to be careful about which hemisphere you're in for your two locations. Let me draw you a little example over here. If your given location in the problem is 30 degrees north, and on the day that you're given for the problem, it turns out that the solar declination is 10 degrees south, these places are not in the same hemisphere. The distance between them is 30 degrees to the equator, plus from the equator to 10 degrees south, the distance is actually 40 degrees. In contrast, if let's say that the problem gave you a location that you were solving for the sun angles at 30 degrees north, and you used the date in the problem and you found out that the solar declination was 10 degrees north, well, now the distance here is only 20 degrees because they're both in the same hemisphere. You're just going from 30 degrees over to 10 degrees. Make sure you know how to do all that. I don't know whether the exact problems on the test will have that. There certainly are ones, though, that are that have that in the test pool. So it just sort of depends on which ones get chosen. So let's do a couple quick examples here. Let's compute the sun angle at 40.5 degrees north on December 21st. And I didn't just pull these numbers out anywhere. 40.5 degrees north happens to be the latitude of Omaha, and 21st of December rather happens to have a solar declination of 23.5 degrees south. It's the winter solstice. All right, so if we draw a big globe of the, showing, there's the equator, and here's our given latitude up at 40.5 degrees north, and here is our solar declination at 23.5 degrees south. The distance between them works out to be 64 degrees, and 90 minus 64 degrees is 26 degrees. In other words, the sun angle in Omaha on December 21st is 26 degrees. And I sketched a little diagram here to help you know what that actually means. It means at noon on that day, the sun only gets as high as 26 degrees above the horizon. Oh my goodness, the shadows are long, the days are going to be short. This is not going to be conducive for very warm weather, right? Because the sun is so low on the horizon. There's a lot of beam spreading, just to throw a vocabulary word out. Here's another example. Let's compute the sun angle at 10 degrees north on June 21st. Again, I just picked 10 degrees north at random. June 21st has a solar declination, according to the analemma, of 23.5 degrees north. It is, in fact, the June solstice, so that is the Tropic of Cancer. It's as far north as the sun gets in the course of a year. All right, so if we sketch a globe here with the equator, our given location being 10 degrees north and our solar declination being 23.5 degrees north, we get a distance between them of just 13.5 degrees. 90 degrees minus 13.5 degrees is 76.5 degrees. What does that actually mean? Let's sketch it down here. All right, on that day at 10 degrees north on June 21st, at noon, the sun will be as much as 76.5 degrees above the horizon. The sun is going to get very high in the sky. There's going to be very little beam spreading. There's going to be lots of solar radiation reaching the surface of the Earth. Okay, hopefully these little review just sort of salvages a few points for folks, and please let me know if you have any questions before you take the quiz. This has been Dr. John Shragi.